Okay, now we are going to study another topic in geometry. You can see that circles. You know that circles, right? Circle is not a rectangle, not a triangle. Okay, given circle. How can we tell how large of the circle? Right? So given a circle, right? Suppose it's a pizza, okay. Right? And you want to compare two pizzas, which one is larger, right? So about circle, it's very hard to measure it. It's around the circle. It's not like a rectangle. So suppose you're the first person, right, to study the circles. Now what they can tell, okay? Well, it's easy to measure. By definition, a circle means you have there is a center, and the distance from center to any point on the circle should be the same. So that's called the radius. Okay. So I is the radius. So that's the definition of a circle. Okay. Then the first thing, yeah. So the first thing we have to do is we have to measure the circle with when radius equal to 1. Okay, the circumference. And then you can say, oh, equals pi. Well, actually, this is how do we define the pi when the radius equal to 1. Okay. So the first question is, what is can you measure the circumference? Okay. So we also call in general, it's called the perimeter. Okay. Okay. So circumference, okay, we don't know. So in old days, people trying to measure it, estimate it. Okay. What they can do is you can draw a circle on the, you draw the circle with a radius, or you use a string, okay? Then you cut it and open it, and then you measure it, okay? So that they estimate the circumference is going to be some number, but then they're trying to, this number is sometimes, it's getting better and better, okay? So this is yeah, so then they will get some number. It's very close to, okay, 6.28318, for example. But old days they can get 6.28. That's the estimate, okay? That's the estimate. So now what I'm going to do is I'm going to introduce a definition. Okay? Definition, I'm going to introduce a special number. Okay, I don't know the exact value. Okay, it's very hard to tell. So I define pi to be the half of the circumference of a unit circle. A circle with radius 1. Okay, so this is our definition. So if you are able to estimate the circumference of a unit circle, you divide by 2, and this is about 3.14. Okay, that's all we needed to know. Okay. So this is our definition. Okay, so someone asks you, what is a pi? They can give the number, but the exact answer should be the half of the circumference of the unit circle. Okay. Then, based on our observation, if this is a unit circle, right? Okay, this is a unit circle I equals 1, and here's an arbitrary circle. Okay, this is an arbitrary circle with an arbitrary r, right? So the circumference here is going to be double pi, right? Okay, then you will see that if you do a comparison, you find out the ratio of their radius is going to be the ratio of their circumference. Okay, so that's why here is going to be 2 pi times r. Okay, just multiply by r. If r is double, then if the radius is double, then the circumference will be double. Okay. 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 Of course, 2r is also the diameter. So if this is a d, and if this whole line is d, yeah, if it's called diameter, this also can be written as it's going to be pi times d. Okay. That's how do we get this general formula. Okay, pi is just half of the circumference of unit circle. Okay, so that's the definition of pi. Then I want to see how large of the area. Then it's very hard to measure because we only define, we make our definition for the area is for the rectangle. Okay, and this is a very important theorem in mathematics. If we introduce pi is half of the circumference of the unit circle, then what we get here is a very important theorem. This is not easy to do in mathematics. The area of the unit circle, okay, the circle of a circle with radius 1. Okay, is just equal to pi square unit. The units will be different. Okay, it's pi. That is surprised. Okay, now this is not a given. Okay, so people find out. It's not easy to do it. You have to study advanced mathematics in order to show it. Okay, you cannot just accept, oh, area is going to be pi r. It's going to be pi. Okay, why? Right? Why it's going to be pi? But you cannot prove it. Okay? You just accept this fact. Okay, and because we only define the area for rectangle, then we know how to get the area. We get the area. We not define the area. Its definition and the formula is different. Okay, we define the area for the rectangle, right? Remember, A and the B. So the area is going to be A times B. Then if you have a triangle and this is H, then the area is going to be half of BH. But that is that we derive this formula. Okay, we do not define. Here's a definition. This is a definition. This is then implies this formula. Okay, so but the circle is more complicated. The circle is not. You cannot make a circle as a union of squares or rectangles. Okay, but you can only approximate it. But this is you have to use advanced mathematics. Otherwise, it's harder to get pi. Okay. Now, once you get this, then you look at this unit circle, and the circle with a radius r. Okay. This is a unit circle. Okay. We want to compare the area. Okay. We want to compare the areas. We find out as the ratio of the areas is going to be r squared. Okay, the large area of the largest, because this is we're talking about area. Area is always involved square. So here the area is going to be pi, and this area will be pi and multiplied by r squared. Okay. Yeah, multiplied by r squared. Okay. So I'm not going to give you proof why the area. But it's easy to understand why it's otherwise a pi r squared, because when r, the radius increases, the ratio of the areas will be square of the ratio of the radius. Okay. All right. So this is we got two formulas. Okay. Now we're going to do some exercise. Okay. Here's the exercise. So given the circle and was radius equal to 4, right? So you can find the circumference is 2 pi times r, so that's going to be 2 pi times 4, it's 8 pi, right? And the 8 pi unit, okay? The area is going to be pi r squared. So you will see that r, it's a 4 squared, so it's going to be 16 pi. Okay, numerically, you know, there's difference, it's double, right? But the first one, it's just a unit, right? 8 pi unit. And then the second one is the area is a 16 pi square units. Okay, so that's the unit difference. All right, now our next problem is we not only give with a radius, we sometimes we are given just a circumference, okay? So if the circumference equals, that circumference equals 9 pi, okay? For example, centimeters, what is the area? Okay, what is the area? So to solve this problem, there's no direct relationship between the circumference and the area, right? There's no direct relationship between the circumference and the area, but we can find that's a two-step problem. We can find the radius, right? First of all, you write on the formula when you do the problem. Okay, you write on the formula, and you write down here. It's c equals 2 pi r. A is going to be pi r squared. So the key point is to find the radius. Okay, right? And based on this formula, okay, 2 pi r is going to be 9 pi. Okay, so you don't need you don't need a pi here. The pi can cancel, right? And then you have to get r. R is you have to 9 over 2, 4.5. Okay, but use the fractions here. We don't need to use decimal point. Okay, so that is a radius. Okay, radius is a 9 over 2. Then you plug into the formula pi 9 over 2 squared, and the pi and 9 is going to be 81. 2 square is going to be 4. Okay, so that will be the answer. Okay, yeah, you Crystal, you know, we don't use a decimal number in the decimal form. Okay. All right, now to do other problems, okay, to do other problems, we can we should understand the radicals. Okay, let's go back to radius. How do we define the radius? Given a positive number. So what is a square root a? Okay, square root a is a number, okay, such that it's a square. Okay, square root a is the positive number. Okay, positive number such that square root a square is going to be a. Okay, that's very important. Okay, so so if we have so then from here, you know, for example, yes, what is the square root of 16? Because 4 square is going to be 16. So that's why you have, you get, you know, that is not nothing but 4. Okay, because 4 square equals 16. You only have one number whose square is going to be 16. Okay, clear? Okay, square root of 16 is going to be 4. Now, square root of 5, it's not going to be integer. Okay, square root of 5 is not going to be integer. Square root of 5 because we cannot find the integer whose square is going to be 5. Okay, if you really want to know the geometry meaning of the square root of 5, you can see that square root of 5 is square root of 2 square plus 1 square. So that means this is going to be the this is 1, here's 2, this is the length of the diagonal. Okay. Okay, this is the length of the diagonal. Right. All right, so we got this, right? Now we can yeah, when we do the simplification, we can also, so if A is positive, B is positive, then the square of A times B can separate. We can also have square of A over B is going to be square of A over square of B. So those are a couple formulas we can use. Okay. All right. So now let's look at the following problem. If the circumference of a circle is before unit, okay, what is the area? Okay, and sometimes we're given the area, and I have to find the expression. So this is we don't know the radius, right? We know this connection is unstable. Right, so it's 2 pi radius, right? And that is going to be 4. So from here, what you can get the radius. But the radius is going to be 4 over 2 pi. And after you simplify 4 divided by 2 is 2. It's pi over 4. 2 over pi. Okay. Now don't simplify. This is a number. Okay. It's a number. Okay. Then the area is going to be, okay, pi r squared. So let's compute it. Pi r squared. And let's try to simplify. Okay. So here's a pi. Here's a 4 pi r squared. Now you have 1 pi in the numerator, 1 pi in the pi squared in the denominator. After you simplify it, it's just pi of 4 over pi. Right? This is a square unit. Okay, so that is our answer. Okay, and sometimes you are given the area. Okay, if the area of a circle is going to be 4 square units, right? The square centimeters. Okay, what is the circumference? Okay, so we're trying to, if we know one of them, we're trying to get the others. Now, can you derive this formula? Derive the expression for the circumference? Anyone have answers? All right. So you draw the circle, right? Draw the circle. You mark it as radius. So the area is going to be pi r squared, which is going to be 4. Okay, got it. So r squared is 4 over pi. So can we solve for r? Yes, right? R is going to be square root of 4 over pi. And now we can simplify a little bit. It can become square root of 4, square root of pi, and square root of 4 is 2. We can express in this form. Okay. Then the circumference is 2 pi r. So it's 2 pi. What is r? R is this. Okay. Now can we simplify a little bit further? And the 2 times 2 is 4. Pi over square pi. Can we simplify? Pi over square pi is going to be square pi. Why? Because pi is going to be square pi times square pi, right? And we have square pi, so cancel it out. So it's 4 square pi. So that is it's a little bit strange, okay? And that should be the answer. Right? Okay, so first of all, you have a circle, okay? You are given the area. Now you want to find the circumference. Okay, you want to find the circle. So if you know the radius, then just the 2 pi r, right? But you don't know the radius. So you have to find the radius from the area. But area related to the radius by this formula, a equals pi r squared. Right? So then you try to solve for r, because if you don't get r, so you're not able to get the radius. Okay. So r squared is going to be 4 over pi. So you have to find r. You just take a square root. You put a square root on the top, all right, over this number. And you can simplify a little bit. Once you get r, then you put the formula in. This is called two-step problem. Okay, that's called two-step problem. All right, first of all, if a student, I don't know why you change the name, okay, N-E, lots of E, okay, you have to change the name back, okay? So when you log in, okay. Yeah, square root of pi, not, yeah, this is not square, just cm. Yeah, this unit for the circumference is just centimeters. Okay. All right, now let's do a project. Okay, what is the project? The project is if you have a pizza, okay, we assume the thickness is the same. Okay, I'm going to assume that the pizza has radius I equals 8 inches. Okay, you don't want such a big pizza, so you ask your mom to make 2 smaller pizza, identical, but then they should have the same area. So you have to tell your mom what is about the radius of the circle, okay? So that the sum of those 2 circles have the same area. So you have to use a calculator estimate, but you have to find a way to do, right? Okay. So the area of the larger circle, that's a condition, is going to be equal to the sum of 2 identical circles with radius r. So you have to say, what is r? You have to estimate. You can say like 2.4 inches. Then you measure it. Then you make 2 identical pizza. The same thickness. Okay, right? So this is very important project, right? And now you are able to. Otherwise, you can only do you cannot tell even the same, right? So the first one, let's find the exact value. Then we can estimate. Okay, so because your mom maybe has, I don't know what is square root 2. Can you tell me? And then you use calculator, estimate, right? You have a scientific calculator. Okay. Kevin just say it's a 4. We're not talking about the size, the one-dimensional size. I'm not talking about the, how big. Okay, we're talking about the area. Okay, when we compare the area, we don't compare when we say one-dimensional size, it means from left to right how long it is, right? So this is a common mistake. We just say it's 4, right? So if I wanted to make 4 identical circles, right? So they have the same area. Then you say, okay, 8 divided by 4 is 2. No, it's wrong. Right? So you have to do the calculation. What is the area of the larger circle? The area of the larger circle is going to be pi a squared. Okay, and this should be equal to the sum of 2 area of the small circle, right? So you just set up an equation like that, right? Then you will get, then you get, right? So pi is gone, right? 16 equals 2r squared, right? Pi remove the r, pi. So r squared equals 8. 8. So r is going to be square root of 8. You can simplify a little bit. You can say 2 times 4. So it's 2 square root 2. Okay. But you can also just interact any scientific calculator you can give is a rough estimate. Okay. Right. So if you really don't have a calculator, you can make a unit square with 2 sides. Then you tell mom, hey, this is a measurement, in case if you don't have a ruler, right? So you can make a unit square, and that should be square root 8. Okay, that piece. So the radius should be equal to that, 2 identical. Okay. Then you choose a one vertex, and then you circle around, draw the circle, okay, around the one vertex. Oh, sorry. You're right. I'm good. Let me redo it. Okay, that's my mistakes. Pi 64. Okay, so r squared is going to be 32. R is the square of 32. Okay. Let me change that. Instead of 2 here, it should be 8. Should be 4. All right. So this is going to be square root of 16 times 2, right? So it's going to be 4 square root 2. Okay. So the idea is, let me draw the picture here. Okay, sometimes I'm confused. Okay, this is a 8, right? And I divide it into half. Okay, right? That's what becomes 4. Okay, then I draw. This radius is 8, right? So and then I choose a 5 point. So I can draw circles with I need a square, not just half of them. If you just use a 4, then it's not, right? So you can get a square. You draw the square, okay? And this is the radius I want to get, okay? 4 times, okay, so square 38. Okay, then you draw the circle as around that that is it. Yeah, these two circles will give you two identical. Yeah, add them together is that exactly equal to the same area, okay, of the larger circle. Now, if yeah, drawing that. If this is radius, right? If I choose a middle point here, draw the circle. If you use a radius equal to 4, and you see that those two circles do not occupy the whole larger circle, okay? Right? Here's a 4, okay? Why? It's obvious, right? So you need a larger circle, larger than the circle with radius equal to 4, okay? Okay. So the radius here must be square root of 32. Right. Right. Our next problem is the following. Okay. You have circles, two circles. Okay. One is they both share the same center. Okay. One circle is I equals 1. Another circle I equals 2. Okay. And we try to find out the area of this shared region. Okay. In other words, yeah. So what is the area of this shared region? Okay. What is the area of shared region? Can you work out this? Any ideas? Yes. Okay, so that's great. So area is going to be pi 2 squared, the area of the larger one, and the area of the small one. What? The area of the small one. Okay, so that's easy. Okay. The next problem will be, so it's a 3 pi. Okay, it's going to be 3 pi. Okay. So the next one is a little bit difficult. I still have the area circle with radius r, okay? Then I'm trying to find another circle larger than that. This is radius r, okay? Such that the area of the shared region is going to be the same as the area of the inside circle. Okay. Okay. So find r such that the area of the shared region is equal to the area of the inner circle. Okay. Okay. Now, how do you do this problem? Well, you already get the idea, right? So the area of the shaded region is going to be the area of the larger circle, which is pi r squared, minus the area of the small circle, right? Oops. Area of the small circle, which is pi 1 squared. And that should be equal to the area of the inner circle, which is small circle. Okay? So this is identity. Then you will see pi will be gone. So r squared minus 1 squared equals 1 squared. So r squared equals 2, right? So r should be equal to square root 2. Got it? All right, so if we get this, the next problem I wanted to do is as follows. Okay, I know that okay, a circle is inscribed in a square. Okay, so that means the circle is inscribed in a square. Okay, find the ratio of their areas. Okay, doesn't matter. Usually it means the circle area of the circle is over the area of the square. Okay, okay. So the area of the circle of the area of the square. Okay, so can you get it? Can you simplify it and find the answer? And definitely this is a number is smaller than 1 because the area of circle is smaller than the area of the square, right, from the picture. Okay. Nobody gave me the answer. Okay, then you have to find a relationship between the ages and the radius, right? So first one, you write down this. Okay, it's pi r squared, and that is a squared, right? But if you have to know the relation between r and a, and r and a, clearly, right? A is going to be double. It's going to be the diameter of the circle, right? A is going to be the diameter. So can you see you actually upside down? That this 4 should be in the denominator, right? Right? A is going to be double the radius. So that's why pi r squared, and this should be 2r squared. Okay, and then you squared. Here's 4r squared. R squared is cancelled out, so you get pi over 4. So pi over 4 is a number smaller than 1. Why? Because pi is 3.14159, right? And 4 is larger than that. So this is a small number. Now, when you get a number, after simplifying, you have to double check whether this number is smaller than 1. Okay? Whether it's smaller than 1. If it's larger than 1, definitely it's wrong because the area of the circle is smaller than the area of the square. So you should get a number and that's smaller than 1. All right. Charles, do you have a questions? Right, so it should be pi. So Candice, when you get 4 pi, right, you see, oh, that should be wrong. Okay, because this is a small, this is larger than 1. Okay. All right, now our next problem is follows. Okay, I have loss. So I put the 4 circles here, exactly. Okay, so 4 circles occupy this rectangle. Okay, so what we want to do is we want to find the ratio of the total area of the 4 circles to the rectangle. To the area of the rectangle. Okay. Okay. So can you do that now? Yeah, all the circles have same radius. Just that's just for those 4 circles are inscribed in the rectangle. They touch each other. Yeah, this is a touching point. Okay, and they are rectangle. They have the same radius, definitely. Okay. All right. So all I have to do is just, this side is A, right? This side is B. And then the radius, right? Okay. Now, let's count, okay? Clearly A equals to R. What is B? How does B related? Okay, 1, 2, 3, 4. I think it's eta, right? Eta. Got it? Right? B equals the 4 times the diameter of the circle. So it's eta. So the ratio is going to be right? The ratio is going to be the total area of the 4 circles is going to be 4 times pi r squared, right? Then the area of the rectangle is A times B, right? That's the first step. Right? Then you're trying to get rid of R, replace A by pi. That's 2R, so 8R, okay? So you will get pi. And then you get 4. Right? So still pi over 4. The same number, doesn't matter how many circles on the way, Okay. Good. So our next problem is, suppose you have a cake, okay? I equals 4 inches, okay, this cake. And but you want to make a cake a square type, okay? You want to make a cake square type. Okay? And if they have the same area, what is the edge length you have to wear? Give me the estimated edge length, right? If they have the same area, okay, what is A? Okay, right? You want to, instead of a circle, suppose you buy 2 containers, right? One is a circular container, another one is a square container. You want to make sure both give you the same area, right? So even you change the shape of the cake, you still get the same area. So we assume the thickness is the same thickness, right? So you have to, one circular container's radius is going to be 4 inches. So you want to estimate, suppose you're an engineer, you want to design a square type of container. You want to make sure they have the same area, so even different shapes, right? So that's the first thing you can design. Now you can also design other shapes, okay? Ellipse, whatever, right? So it's more complicated. So that's why you need a mathematics, right? So give me the estimate of it. Tennis. Tennis. You don't make a guess. You have to compute it, okay? Okay, this is a project, right? So probably, you want to design a square type of container. You want to make sure they have the same area. Casey gave me a different answer. Good job. Okay. So you just compare, right? Both sides, that's area, pi, right? So pi 4 squared, right? And the other side is a squared. Just look at that, right? So how do you solve for a? A is going to be square root of pi 4 squared. And then square pi and square 4, square root of 4 squared. So it's 4 square pi. All you have to do is just find the scientific calculator. You enter pi, enter square root, okay? Then multiply by 4, and you get a rough estimate. Then you say, hey, this is how do we design, you find this, right? Right. Our next problem is, we have a circle. Another circle, okay? And a square is in square of the circle. Okay, a square is inscribed in a circle. Okay. Let's find out the ratio. No, what is this? Yeah, let's find the ratio of this of the area of the square and to the area of the circle. Find the ratio of area of the square and the area of the circle. Okay. So let me explain to you. Okay. So the radius, right? Now, if we draw the radius correctly, you already have the answer here. So this is the radius R. That is A. So we want to find out A square of a pi R square. Yeah, who can give me the answer? Okay. So what's the relationship between A and R? Can you figure it out? Right. So here's the idea, right? You have to use the simple Pythagorean theory. You can try this, right? You can try this. You can draw this. So those are the right triangles, right? So R squared plus R squared should be equal to A squared. That's it. So A squared equals double of R squared. Okay. So that is why it's double of R squared. Okay, the answer is 2 over pi. 2 over pi, of course, is still smaller than 1. Okay, right? Yeah, we already learned the simple Pythagorean theory. Okay. Right? So this is R, right? R squared plus R squared equals A squared. That's it. Okay. So now I'm going to have a semicircle. Semicircle with radius R equals 1. Okay. This semicircle has the same area of the circle. Okay, with radius capital R. So they have the same area. Okay, so what is the value of R? What is the value of R? this this semicircle is, you know, make is equal to the area of the large another circle. Okay, so they have the same area. So can you figure out the radius of this other the circle? What? What do you say, Nina? Well, just come on, just semicircle, right? The area of the semicircle is pi r square, by 2, right? Because it's half. The area of the circle would be pi capital R square. And that's it. And you cancel this pi. So R square is going to be 1/2. So what is R? The square of 1/2. Right? That's how you solve the equation. The equation is very simple. Okay. Yeah, one more question. I have the semicircle. In the semicircle, I draw, this is the middle. I draw an isosceles isosceles of triangle. Okay. So the question is, what is the ratio of the area of the rectangle, a triangle, and the area of the semicircle? Okay, I'll give you 2 minutes to look at. Anyone? Okay, got it? Well, you don't get it, right? Some of you don't get it. So how do you do that? Well, first of all, this center, this is the radius, right? So clearly, the bottom part is pi 1 square divided by 2, right? The triangle, the base is 2r. And this is r square, right? And the height is just r. So you just get r squared, right? And the bottom part is pi r squared divided by 2. And then r squared simplified, and it's 2 over pi. Okay, 2 over pi. So that's it.